All right, this lesson is on fundamental trigonometric identities, and let's just get right into it. Okay, so some of this you're already familiar with. Actually, a good chunk of this is pretty familiar. Let's quickly review a couple of things. First of all, if you remember in the unit circle, cosine theta is x, sine theta is y, and tangent is y over x. So another way to say that y we already know is sine theta and x is cosine theta. So we can also write tangent as sine theta over cosine theta, and that's where this first one comes in. It's called a quotient identity. And then this other one kind of follows along. Since tangent and cotangent are reciprocals, I can just flip that around and I have cotangent. And then down here we just see these right here are called reciprocal identities because they are just reciprocals of each other. Sine theta and cosecant theta are reciprocals, so you can write them, for example, you could write sine theta as 1 over cosecant theta and vice versa. And that follows with the other two pairs as well. So for me, I really want to take some time and focus on the bottom three, which are called Pythagorean identities, and these are pretty crucial. Again, the rest of them you kind of are already familiar with. So let's take a little bit of time to do that. Okay, so if you recall, let's just, I'm going to draw a unit circle here. Okay, so in the unit circle, say I have a right triangle. This would be my x then. This is the height, so that's y. And in the unit circle, the hypotenuse here would be the radius. We usually say r, but we know that in the unit circle that's 1. So if we use that and our Pythagorean theorem, we get x squared plus y squared equals 1 squared. Well, we just said that in the unit circle, x is cosine. So this would be cosine squared theta. And cosine squared theta just means cosine theta times cosine theta. And then y is sine, so this would be sine squared theta. And 1 squared is 1. So right here, that is our first Pythagorean identity. It just comes from the unit circle and the Pythagorean theorem, thus the name. So, all right, that's the first one. We can actually derive the second one just from this right here. So how do we do that? Well, let's switch some colors here. Let's go this. One of the things that we can do is say, okay, what happens if I take everything here and divide it by cosine squared theta? Divide by cosine squared theta. Okay, well, cosine squared theta divided by cosine squared theta is 1. Sine squared theta divided by cosine squared theta, well, up top here, we said that tangent is sine over cosine. So sine squared theta over cosine squared theta would be tangent squared theta. And we also know that 1 over cosine is secant, so 1 over cosine squared theta would be secant squared theta. Okay, so now I really have this second one. I just got to rearrange the tangent. Doesn't really matter here, but just so for consistency's sake. And that's how the second one is derived. By the same token, you can also do this third one, and instead of dividing everything by cosine squared theta here, if you just divide everything by sine squared theta, you would get this last one here. So that's where those three Pythagorean identities come from. And in the next video, we are going to begin to apply these, all of these, but mostly the Pythagorean identities to begin with. Okay, that's it.